We've talked about circles before, and we've talked about how to find the area and perimeter of circles. But what about parts of a circle? So this is a semicircle, and it's half of a circle. So what do you think would be true about its area compared to a full circle? You're probably thinking that it's just half, because it's half of the full circle, and so the shaded in part would also have half of the area. What do you think you could say about its perimeter? So if I'm just thinking about the perimeter as including just this part, without this straight line, what do you think you would say? How would this compare to the perimeter of the whole circle? You can probably see that, like the area, this perimeter of the semicircle is half of the perimeter of the whole circle. It just goes halfway around. But what if you do include this straight line? Now you're going to have to do a sum, because it's this part, which is half of the perimeter of the circle, plus this part. Can you think about how you'd actually solve that? So let's say that this circle had a radius of 2. What would be the area of, or the perimeter of the circle, also known as the circumference? Our formula is that the circumference is 2 times the radius times pi, or just this diameter times pi. So in this case, if the radius is 2, our circumference would be 4 pi. But that's going all the way around. So what would be just this part? Well, this part would be 2 pi, half of the full circle. But if we want to include this straight line, do we have any information about that? We'll take a look. What's this distance? This is just the radius. So we know that that's 2. What about this? This is also a radius. So that's 2 also. So our overall perimeter would be 2 pi plus 4. What about other fractions of a circle? So we saw that a semicircle, which was half of a circle, had an area of half of a circle and a perimeter of half of a circle, as long as you didn't include this part. But what about this fourth of a circle? Probably it's easy to see that that area is just a fourth of the full circle's area too. And its perimeter, if you don't include these straight lines, would be just a fourth of the overall circumference. What about a 16th? Well, you're probably thinking, you can see the pattern, that would have an area of a 16th of the full circle. But what about this one? A sector that has a central angle measuring 18 degrees. Now that's a little bit weirder. Do we remember what these words mean? A sector is a piece of a circle, and the central angle is this angle right here. So if we know that this is 18 degrees, I haven't told you what fraction of the circle it is, but can you figure it out? If you went all the way around, how many degrees would be in the full circle? I think you probably remember that that's 360 degrees. This fourth of a circle would be 90 degrees out of those 360. That's how we know that it's a fourth. So if this were 18 degrees and we wanted to see what fraction of the circle it is, we could just say it's 18 degrees out of 360, and then we can reduce. 18 goes in here once, 18 goes in here 20 times. So this would actually be a 20th of the full circle. What about the length of its arc, this piece right here? Well, it's just a 20th of the overall circumference. So we have these two formulas that we can think about. If we know what the central angle is, we just can calculate what fraction of the circle we're talking about by taking that number of degrees over 360 and then multiplying it by either the overall circumference, 2 pi r, or the overall area to find these quantities. Why don't you pause this and get those formulas written down? I want to add one more piece of vocabulary, and that's that when we talk about a sector, so we've divided a circle up into pieces, we can talk about two arcs. One is a minor arc. That's something that's less than a semicircle. And we can also talk about a major arc. That's the one that's going the rest of the way around, which is more than a semicircle. So we always have those two different arcs anytime we cut up a circle. Here's a more complex shape. Can you find the perimeter and area of this shape? Let's think about the area. If we are finding the area of this shape, we know that it's equal to the area of this shape plus the area of this shape. Can we find those? This is just a rectangle. Can you pause and think about what you would do here? We know we can multiply the base times the height to get that this part is 60 units squared. What about over here? What shape is this? This is a semicircle with a radius of 5. Can you pause and think about what the area of this semicircle would be? It would just be half of pi times the radius squared, which would be 25 halves times pi. So our area overall would be 60 plus 25 halves pi. That's just 12 and a half. I could write it either way. And I could, if I wanted, use 3.14 to plug in here. Can I combine these? Are these like terms? Can I say that 60 plus 12.5 pi is equal to 72.5 or 72.5 pi? A lot of people want to do that because they want to combine like terms. But these are actually not like terms because this is not actually 12.5. It's 12.5 times pi. So this is actually something more like 40 than it is like 12. So we actually cannot do this. This is a common mistake that people make. Let's take a look about the perimeter. What is the perimeter of this shape? So the perimeter of this shape actually goes like this. It goes just around. This dashed line is showing, it's kind of breaking the shape up into two pieces so that it's easy for you to visualize. But this is not part of the perimeter. That's not what we trace if we're going all the way around. So we need to find the perimeter by adding up this length, this length, this length, and this length. Now here's a pro tip, and that's to trace over these lines with your pencil as you add them into the perimeter. Because what I see all the time is that people will forget one line. So maybe they add up this, this, and this, and they've forgotten to add this part in. Or maybe they accidentally add in this part. They just recognize this as a rectangle, and they want to put in the perimeter of this rectangle by saying 6 plus 10 times 2. And so if you trace over things as you go, you'll be able to tell more easily when you've added up everything and not double counted anything. So let's go with this. So I'm going to see this side is 6. This side is 10. This side is also 6. I'm not going to include this side because it's actually not part of the shape. It's a dashed line. And then I have to think about this side. And this is a semicircle. So it's going to be half of the circumference of that circle. And that circumference was just 2 times the radius times pi, but then those will cancel. So this actually ends up just being the radius times pi. That's kind of a cool thing. I can combine these like terms. Can I combine these? No, these are not like terms. This is actually 5 times 3.14, so this is a little bit more than 15. So I can't combine those. I could, if I wanted to, I could find the exact answer, or at least as close as we want, because we of course have to approximate pi. I could do this multiplication. And then I could add it. to get the total perimeter. But otherwise, if I'm going to leave it with pi in my answer, this is as far as I can go. I can't come by. That's it for the slides. I would like you to do the practice set A, B, C, and D on page 725 and bring that to class tomorrow. It says to use 3.14 for pi and solve things exactly, but that kind of can take a little bit of extra time. So I'm going to invite you to leave pi in your answer and bring those, and I see you tomorrow. Thanks. Bye.